times 0, it will give me 0 times x raised to power minus 1. But don't forget, when I multiply this one, everything will give me 0. That is why you have the derivative of a constant to be 0. Now, in this case, I will get my answer to be 6x plus 4. X raised to power 0 is 1. Then I will have this one. That is ordinary differentiation. And this one is possible when you are differentiating a function that has only one dependent and one independent variables. All these variables are real. We call them real independent or real dependent variable. Now, under that one, you discuss many methods, chain rules, product rules, and so on and so forth. But we are going to do the same thing here. But what is the difference from this one and this? I can have a function of more than one or two independent variables. That is why partial differentiation was defined as differentiation of a function which contain or which have more than one real independent variable. How do we have a function that have more than one real independent variable? If I have my function to be this, my f of x, y, if I have my z is equal to f of x, y, my z is equal to function of f of x and y. It means in my function, this is only dependent variable now. Z is my dependent variable. X and y are independent variable. How will I divide the differentiation of this function? This function f of x, y. Now let's go. If I want to differentiate these two functions, of two variables, what I would need to do is I will consider one of them at once. For example, if I want to differentiate this function with respect to x, this the y, the x that I used to write means you are differentiating y with respect to x. Differentiating y with respect to x. Now, I can differentiate this function with respect to x. It means in this case, this y will be constant. I will treat y as constant. It means I consider the movement on x-axis while y-axis will stay unmoved. The same thing, if I want to differentiate this function with respect to y, x will be considered as a constant. And that's what we want to do. Now, if I have this function f of xy, this function f of xy, the derivative of this function with respect to x, if I want to divide it with respect to x, I will write instead of d. Now listen to how I will pronounce the symbol. The symbol is written this way, and it is pronounced del. Del. It's not d this time around. It's pronounced del. Del. So if I want to write it, I will now write del f of xy the x. I want to divide this function with respect to x, which is limit the delta x tend to 0. The limit at delta x tend to 0 will now give me f of x plus dx. Don't forget, as delta x tend to 0, this one partial will change to total derivative, comma y minus f of x comma y, everything upon the x. That is derivative of this function with respect to x. It will give me this one. Now, if I want to, the derivative of f of xy with respect to y is the f comma y of the y is limit delta y tend to 0 of f of x comma y plus the y minus f of x comma y everything upon the y, everything upon the y. Or since I'm taking the limit, if I like, I change or even this one to delta. Let us do this one to delta state. If we like. But what this one is telling us is that you will see what I have just done here is this. You can see there is change in x. Change in x. Like you are using the first principle in ordinary differentiation. X change, but y remains the same. Here, y change, but x remains the same. It means here, y is constant. Here, x is constant. And that is how to do it. We just differentiate one, you keep one constant. But in this case, let us consider some notation. Let us see some notation for this block. Yes, if I have many variables that's more than 2, I can have many of them. Let's assume I have f of x1, x2, x3 to xi. Many of them. Many. Then if I want to differentiate this function, the f of x1, x2 to xi with respect to xi. I want to differentiate with respect to xi, it will just give me limit the xi tend to 0 and of f over x1, x2 to xi plus the xi over the xi, this one minus f of x1 to xi. So it will give me that one. That is if I have many functions there. If I have many functions there, it will give me that. Now let us consider some notations. Let us consider some notations. What are the ways by which we can write the y? Okay. Let me, before I will define it, if I have my y to be equal to f of x1, x2 to xi. Yes, if that is my y. Now y comprised of many x. xy is not equal to x2. If I have many of them like that, how will I write the y, the xi? What are the other way in which I can write the y, the xy? That is, I want to represent that y with respect to xi. What are different way in which I can write it? I can still write it as a y of xi, y subscript x subscript I. I can still write it as a d. Okay, let me write very good d. D of xi y. Y is my function. I want to differentiate with respect to this. Y is my function. I'm differentiating with respect to this. That is just it. Then, what are the other way? I can still write it as a. The f of xi over. Sorry, the f of xi, the xi, or f of xi, this f is a function of xi, or the xi of f. So I can write it in different way. So if you see any of this one in test or exam, so they mean the same thing. They mean the same thing. Now let us consider an example. Let us give ourselves simple problem. Then we'll see. Yes, we want to find the f. Can you see? The f of xy, the x, and the f of xy, the y. Given that our f of xy is this, we want to differentiate this one with respect to x and y, respectively. Solution. Look at the f comma xy, the x. It means the of x squared minus 2y squared, the x. It means I want to differentiate this function with respect to x. Here there is no x there. Then it's a constant, perfectly constant. With respect to this brother now, it's a constant. Then the derivative of this term will be 0. Now we'll concentrate here. Differentiate x raised to power 2. This one will give me 2x. That's all for that. Now the f comma x comma y, the y is that of x squared minus 2y squared, the y. The y. The same way, this brother is a constant. There is no y there. Yeah. And the differentiation of constant is 0. Forget about x as a variable. This x now to this. When we are in secondary school, we are taught weed in agric science. They tell you weed is any plant that grow in a place where it is not wanted. It's a plant though. If maize grow inside cocoa farm, it becomes weed. And maize is a plant. X grows here now. Is useless because it's no y. It's a constant because it's no y. So here I only consider the term that have y as variable. They can vary. This one is constant. Then differentiate minus 2y squared. 2 times minus 2 will give me minus 4. Minus 4y. Then if I remove 1, it will give me that. And that is the solution to that problem. Okay. Look at this. Look at this simple one. Evaluate fx and fy if fx comma y is equal to sine square x cos y plus x over y square. My God, that is very simple. Now, okay, let us look at this question. There are many things inside. This first term is a product rule. This second term is a quotient rule. I will apply all those rules, but with respect to what I want to do. Just the rule. Look at the solution. I have my f of x, comma y to be sine square x cos y plus s square, x over y square. Yes, x over y square. I have that. Then what is my f of x? F of x means the sine square x cos y plus x over y square, the x. Don't forget, in product rule, I will differentiate one, keep one constant. Differentiate one, keep one constant. Now, let me keep this one constant. It's the same thing as sine square x, the x of cos y in this place. Then plus, I want to differentiate this one now. Cos y, the x of sine square x, that is for this brother only. Now to this brother, plus to this one, I will have, don't forget the formula is v square, sorry, v, the x of this brother x minus u, this is my u, the y square of x, we are differentiating with respect to x, over v square, y square, everything square. That is it. Then, having applied that method, we want to differentiate each of them one by one, one by one. Okay. In this place, there are many things that has gone away. Okay. If I come here, the derivative of this one is 0. Of the cos y with respect to x is 0. So everything here will be 0. Plus cos y. Look at sine square x. I cannot differentiate sine square x just like that. I cannot differentiate sine square x just like that. Sine square x means sine x, sine x. Then I will differentiate sine x, sine x. The x, sine x plus sine x, the x, sine x. Plus, I come here, the derivative of this one is 1. The x dx, 1. Half y square. The derivative of this brother is 0 with respect to x. Minus 0 over, derivative, this one, y square square is y raised to power 4. Yes. Here, I will have cos y into, if I come here, I will have cos x. Then this brother will be multiplied by cos, no, this sine x will be there. Multiplied by the derivative of this one will be cos x plus sine x multiplied by cos x plus y square over y raised to power 4. This one will go. Then this one will give me cos y into cos y into, look at sin x cos x plus sin x cos x. They are the same thing. This is 1 plus 1. 1 plus 1. Oh, I'm supposed to cover this bracket here. 1 plus 1. That one will give me 2 sine x cos x. 2 sine x cos x plus y cube over 1 will give me 1 over 1 raised to power 2. By the time I divide that one to give me 1 over y raised to power 2. Now let me open the bracket. If we open the bracket, our f of x will now be equal to 2 cos y sine x cos x plus 1 over y squared. And that is the derivative of that function with respect to x. This one can be written in any way. If somebody writes 2 sine x cos y, somebody writes 2 cos x sine x cos y, they are the same because it's product. Then this one, leave it like that. Now let us go for f of y. And f of y is the of sine square s cos x plus x over y square the y. I will apply the same rule like this, but with respect to y. Then that one will give me here I will differentiate. I will keep this one constant. I will differentiate this one. Is that one correct? Is that question correct? This one is cos y. I will keep this one constant. Differentiate this one. I will now have sine square x the dy of cos y plus I will now differentiate this one, keep this one constant, cos y the dy of sine square x plus this one will give me y square the x, the y, minus x, the y square, the y, everything over y square, square. Yes. This is v du dx minus u dv dx over v square. Then, from that angle, I'll cover this, brother. From this angle, this one will give me, don't forget, here, the value of x in this respect to y will be 0. Everything here will be 0. I will come here. This one will give me sine square x multiplied by minus sine y. The derivative of course is minus sine. Minus sine y plus 0, all this place will be 0. All this place will be 0. Plus, I will come here, the derivative of x with respect to y will be 0. It will give me 0 minus, I will come here, it will be x, differentiate this brother, y square, give me 2y, everything over y raised to power 4. Yes, from that angle, this one will not be equal to, if I multiply this one, open the bracket, it doesn't give me any meaning. I'll get minus sine square x sine y minus sine square x sine y here. This one will be 0. This one will give us this. But look at this one, it will be 0. Do not give me minus 2xy over y raised to power 4. But this y can take away 1 from here. Can take away 1 from here. I will now have minus sine square x sine y minus 2x over y raised to power 3. and that is derivative of that function with respect to y. With respect to y. So if you want to differentiate with respect to x, with respect to y, just any rule you are using, then you consider the variable you want to differentiate. Now, the same way you consider higher derivative in ordinary differentiation, we can do it in this brother. Higher differentiation of function. So we can do it in this partial differentiation. And that is the next thing we want to consider. Higher partial derivatives. Higher partial, yes. The same way, as I said, in which you can find second, third, fourth, fifth, and so on of ordinary derivative, of the ordinary function. The same way, if we have a function of more than one independent variables, I can find second, third, fourth partial derivative. But mind you, in ordinary differentiation, if you want to find higher derivatives, you find the derivation of that function with only one variable every time. The y dx, the square y the x square, the cube y the x cube, you get to 1,000,000 times. But in this case, I may change my style. If I have a function that have, look at this function. If I have x, y, w. So I want to find the higher derivative. I can find the derivative of this function 3 times. And it may not be of the same variable. I can find this one to be the f, the x, the y, the w. Can you see? I want to differentiate this f. First time with respect to x. Second time we now go to the with respect to y, which is the second order. Then the third order will go to with respect to w. Can you see? It's not to the same variable here. It's not to the same independent variable. So it can change the independent variable. That is the only difference in this partial derivative and ordinary derivatives. So, and without what I've explained, you will see it. If I have this, the square f, the x square. The meaning of this one is that I want to differentiate it twice, both with respect to x, this function. The first time with respect, don't forget this one means the f, the x, the x. That's the meaning. It means I'll first of all, or even I may not put bracket in this brother. I'll have the x, the x. Then the meaning is that I'll first of all differentiate this function with respect to x. I'll still differentiate with respect to x. Yes. Even I can write this one like that. Then, if I have the square f, the y square, it means I want to differentiate this function with respect to y, both of them. It may be the y, the f, the y. Both of them with respect to y. And at the same time, I can have this one, the square f, the x, the y. Now I'm considering a function of f of x, y. The square f, the x, the y. This one means the x, the f, the y. I'll first of all differentiate with respect to y. I've not differentiated with respect to x. Now, another one is the square f, the y, the x, which is the y of the f, the x. But let me tell you something. If I have a function in also let me say almost every time, the derivative of this one and this one must be the same thing. Of this, the square f, the x, the y, and the square f, the y, the x must be the same. They must be equal. In exam, I will tell you, verify that this is equal to this, given that I will now introduce a simple function. Piam, and everything will blow up. I just want you to prove to me, show me that the two are equal. Now, let us go to notations in these second derivatives. In these higher derivatives, go to notation. What are the ways by which I can write? If you see this brother, it means this. That is the meaning. And I can write it like, that's just the meaning. If you see this brother, it means this. And I can write it as that. Then, if you see this brother, the xy, f of xy, it means the square f, the x, the y, which is the same thing as d of xy of f. So those are the way I can write that one. Then f of yx, the square f, the y, the x, the yx of f. So those are the way in which I can write all those one. In which I can write all those one. Now, for our time, let us consider, if possible, 2 examples. Under that, then we fly. Okay. Example says, determine or the second partial derivatives of f of x comma y is now here, I don't know, anything x cubed minus 3x squared y plus y cubed. If I say all the second partial derivative, what I mean, the question will just come like that. I need 4 solutions. I need this, I need this, I need this, and I need this for that question. 4 of them. 4 of them. 4 for this brother. Now let us go one by one, pick them one by one, then we'll arrive somewhere. Our f of x comma y will be equal to x cubed minus 3x squared y plus y cubed. Let us go to f of x. Because I cannot find f of x if I didn't find f of x. Our first of all, okay, let me say this one is this, which is del square f of x comma y, the x squared. The x over let me use bracket, d over x cubed minus 3x squared y minus y cubed the x. I'll first of all differentiate it with respect to x, which is equal to the x over, differentiate this one with respect to x, I will have 2x squared, 3x squared minus, here only x, 6xy. Don't forget, if I differentiate x, I take y constant here, I have this. If I want to take this one constant and differentiate y, it will give me 0. I don't need that term. I don't need to go for that. And the derivative of this function with respect to x will be 0. Then I will stop here. This one now will give me, differentiate this one again with respect to x, will give me 6x minus 6y. This x will be 1. Then 6y. Y is a constant. So, and that is the answer for f of xx. F of yy means the square, it means the square f of x comma y, the y square, which is the same thing as the y of the x cubed minus 3x squared y minus y cubed the y, which is equal to the y of, I'll first of all differentiate this one with respect to y. This one will be 0 with respect to y. This idiot is 0. Here it will give me minus, don't forget y will be 1, 3x squared minus, differentiate this one with respect to y will give me 3y squared. Now differentiate this one again, will give me, again this one will be 0 because there is no y there again. Y has disappeared, it will be 0. Then I will go to this term. This term now will give me minus 6y. Minus 6y. Minus 6y. Oh, I've written another thing. This plural is positive. Positive. Oh, it's positive. That one will give me 6y. It's positive. Sorry. It's addition. Change to negative. Maybe because I love negative number. Yeah, it's correct like that. Now let us go to the third one. Let me go to f of xy. That is the square f, the x, the y. And that one means the x, the of x cubed minus 3x squared y plus y cubed, the y. I'll differentiate it with respect to y first. I don't need to stretch myself. I know the derivative of this function with respect to y, which is this. Which is this. So I don't need to stretch myself. I will just copy that one inside. And I will have this. The x over minus 3x squared plus 3y squared. Then we differentiate this one with respect to x. Will give me minus 6x. This brother will be 0. That brother will be 0. Let me go to f of yx. F of yx will be the square f, the y, the x, which is the y into the of x cubed minus 3x squared y plus y cubed the x. Yes, with respect to x first. Then this one will give me the y of differentiate this one with respect to x once. I know the answer already. The answer was here. Where is this, brother? This the first derivative. I'll just copy it. I don't need to rack my brain. I'll just copy it. This one will give me 3s squared minus 3 minus 6x minus 6x. 3s squared minus 6xy, sorry. Because this one will be constant, 6xy. Then if I get that, I will differentiate this one with respect to x. Sorry, with respect to y. With respect to y, this time will be 0. There is no x there. So there is no y there. Then to this time, it will be minus 6. Is it 6y or 6x? 6x. I'm differentiating with respect to y. This one will be 1. So it will be minus 6x. If you look at this and this, I don't know. Are they the same? Oh, look at it very well. You see that f of xy is equal to f of y x. Yes, I will copy the second question. I will do 1. I will leave the remaining 3 for you to do by yourself. 1 no, out of the 4. You will see. I'll just change the question like this. I'll just change this one to example 2. And I will determine all the second partial derivative of f of x is equal to exponential x times y. Exponential x times y. What is f of xy? Exponential x times y. Then let me go to f of x is the x of the exponential x times y, the x. I want to differentiate this one with respect to x first. The x of, now I will use product rule. If I differentiate this one and hold this one constant, the derivative of this one will give me exponential x and the constant of it plus, I will not differentiate this one, I will hold this one constant. But don't forget, the derivative of this one will be 0. The derivative of this one with respect to x will be 0. Then I don't need that time. I will leave it. If I differentiate this one with respect to x again, with respect to x with the same method here, I will get exponential x times y, which is the same thing for that brother. Now, in 1 minute, let me do f of xy for you. You will not do f of xx, okay? F of yy, do it yourself. Now, this one is the x of the exponential x times y, the y. Yes, that is the meaning of that, brother. In this case, this one will be the x of, I want to differentiate this one with respect to y. I will hold this one constant and differentiate this. What is the derivative of tan? This one will give me exponential x sec square y. Exponential x sec square y. Then I will hold this one constant. Differentiate this with respect to y, it will be 0. This one will stop there. I will now come here and differentiate this one with respect to x. Don't forget, I will hold this one constant and differentiate this. It will be exponential x sec square y. Then, if I hold this one constant and differentiate this with respect to x, it will be 0. Then this is my answer. F of yx. You do that one yourself. And that will mark the end of today's class. Next time when we meet, we take a step forward. God bless you all. Thank you.
Finish him. Kill the guy now. You have to come. What? What is this? Good day, sir. You are watching Jackie Pan in my house. No, it's King Kong, sir. King Kong. You've never heard of ACTV before in your life? ACTV is very educative, informative, and there are football sport there. There is entertainment. There are a lot of things you can even attend lectures here. All you know is watch all those nonsense artists and do nonsense, or you watch nonsense on TV. Last night you almost came in bed with your fist.
It's not me, sir.
And you wake up every morning, the bed will be so rough, like you've been fighting for your dream. That's the reason why you have F's in your courses, like especially made for you.
I have V last semester.
We by pounds on you. Very stupid though. Yeah, change that section to ACTV right now. And oh God, the baby to have been first born. Stupid boy.